Hi, and welcome to College Algebra, Section 4.1, Rational Functions and Asymptotes. So, some things we're going to talk about here. What is a rational function? Find the domain of rational functions, and of course, vertical and horizontal asymptotes. Now, we've talked about rational functions before. A rational function is anything that you've written as a polynomial over a polynomial, which is a fancy way for saying a rational function is just a fraction, or something that can be written as a fraction. Because remember, by definition, a polynomial could be a monomial term. So 6 over 1 would be a rational function with two polynomials. Just not very interesting polynomials, because the polynomials would be, 6 and 1. So these are all sorts of polynomials. Now, this causes issues because we run into one of the three domain restrictions that we've been talking about all year. You cannot divide by 0. That's bad. So whenever the denominator equals 0, we have to look out for that. So let's take a look. Here, for example, x minus 2 as a concept can never equal 0, or that would cause an issue because I'd be dividing by 0, which means if I can add 2, and solve for this, therefore x could never equal 2. So if I were to write my domain, I know that I could have every value from negative infinity all the way up to 2, and I would be just fine. Because 2 doesn't work, I have to use it as a parenthesis. I also know that if I was going to start at 2, I could have every value up to positive infinity. And again, because 2 doesn't work, I have to put that as a parenthesis as well. And we've talked about interval notation enough to recognize that if I have two sets of parentheses of my intervals, or using brackets, in this case we don't have any brackets, I would combine them with the union sign. So here my domain would be negative infinity to 2, union 2 to infinity. Over here, we have g of x equals 4x over x squared minus 2x. One thing you should always be on the lookout for is solving, and typically by factoring. Here, I can take an x out of both those things, so I get x minus 2. Well, I could set each individual equal to 0 using the zero product property, so I know that x cannot equal 0, and here x cannot equal 2. So that domain would be even more restrictive. That would be negative infinity all the way up to 0, union 0 all the way to 2, union 2 to infinity. Because x cannot equal 0 or 2. Here, interestingly enough, 3 is never going to equal 0, so this domain is never restricted. It'd be all real numbers, or negative infinity to positive infinity. And then here, lastly, this one's pretty similar. 3x cannot equal 0, therefore x cannot equal 0. So my domain would be negative infinity to 0, union 0 to infinity. Now, what happens at those points that we're talking about, in this case 2 for that first equation, this one's 0, and as well as 2. This one didn't have anything, but this one at 0 as well. Well, depending on what's going on, we could have an asymptote. An asymptote is a vertical or horizontal line that the graph won't touch. It'll get infinitely close, but never quite get there, and it'll sort of level off. You can think about it is a couple units ago, we talked about the big 12 functions and things like, the logarithm function and the exponential function, where we had these sort of patterns, where in the exponential function it looks like this, and the logarithm pattern looked like this. Oh, not quite. It'd be more like this, where they would get infinitely close to these axes, but never actually quite get there. That's what an asymptote is in context. So, how are they created? Well, domain restrictions are typically what causes them. They can either be a vertical asymptote or a hole in the graph. A hole in the graph is what happens when, if you factor everything and you can cross things out and simplify, the x minus 2 component isn't there anymore. But if I go back to the original polynomial and I plug in 2, I would still functionally be dividing by 0. So while it's not quite there anymore in this context, it's still an issue and creates a hole. However, if something stays there, for example, I'm crossing out this 2, this is still an issue. That's what creates the vertical asymptote. I still can't use 3, and that's what creates this line. So let's solve some and take a look. Find all vertical asymptotes and holes. Oh, first way to start often is by factoring. So here I can take out an x, and I'm left with x minus 2. So I have 4x over x minus 2. Well, I can actually cross out both of these x's, which means that x equals 0 has to be a hole in the graph. And x minus 2 equals 0, or x equals 2, would be a vertical asymptote. And we can actually check this by graphing. So if we were to graph this, we get 4x over, goodness gracious, what was it? X squared minus 2x. X squared minus 2x. Let's go to zoom 6 to make sure it's standard. I see this vertical asymptote right here. That looks like x equals 2 to me, though it's kind of hard to see what's going on at x equals 0. If I zoom in enough, it should look like a gap. Let's see if I can zoom in a little further down by it. It's kind of hard to see that gap. I'm going to go back to zoom 6. However, if I always go to zoom table, I can always take a look. And in fact, it says error at x equals 0 because I can't have that value. And here it says error at x equals 2 because, again, those values don't work. Okay. Looking at this one, I should factor the bottom for sure. So what multiplies to negative 6 adds to negative 1? That would be x minus 3 and x plus 2. However, up top, I should also factor this trinomial. So what multiplies to negative 2 adds a positive 1? That sounds like x plus 2 and x minus 1. Well, I end up with x plus 2, x minus 1, x minus 3, x plus 2. I get x plus 2 in both, so I can cross it off, which means x plus 2 equaling 0. X equals negative 2 has to be a hole in the graph. I still can't use it, but because it's crossed off, it's a hole, which means everything left that I didn't cross off is a vertical asymptote in the denominator. So x equals 3 is a vertical asymptote. And that would hold true if I were to graph it as well. So that's how you find vertical asymptotes. Conceptually speaking, if I'm looking at the graph, a vertical line, which we talked about in the past, is when the x value doesn't change. So it should make sense that a vertical asymptote is always an x equals value because it's a vertical line. The x is unchanging as I go up and down that line. Now, those aren't the only types of asymptotes. We also get horizontal asymptotes. Horizontal asymptotes will be a y equals value because that way the y value is unchanging. So the y asymptotes, there's 3 quick ways to check. We basically just check the leading term in the degree. So if the degree in the numerator is less than the degree in the denominator, your horizontal asymptote is always y equals 0. There's a big, long calculus proof to this. For the sake of time, we're just going to admit this as fact. Number 2, if they have the exact same degree, you find the ratio of leading coefficients, aka you divide the coefficients. So for example, if we have, 2x cubed over 5x cubed, they have the same degree, so I would just do 2 divided by 5. So y equals 2/5. And number 3, if the degree of the numerator is greater than the degree of the denominator, there is no horizontal asymptote. The numerator wins the day, if you want to think about it like that. So let's take a look at some. Here, looking at the degree, 5 is bigger than 3. So I know that the denominator degree is bigger than the numerator degree, so it has to be y equals 0. Here, my numerator is bigger, so my numerator degree is bigger than my denominator degree, so there is no horizontal asymptote. And here they are the same. So my denominator degree is equal to my numerator degree. So I have to do 4 divided by 2, y equals 2 for my horizontal asymptote. Okay. Now, some other stuff we can still talk about. Finding those domains as we talked about earlier. The issue is we need to make sure we cover all the bases. So here I could factor. So this is difference of squares. So x minus 5, x plus 5. I don't cross off either. So I know that x equals 5 and x equals negative 5 are both vertical asymptotes. So when I talk about the domain, I can't have either. So I would get negative infinity to negative 5 union, negative 5 to 5, union 5 to infinity. Okay. I also would note that I have a horizontal asymptote because my degree in the denominator is bigger. So I also get the horizontal asymptote of y equals 0. Okay. On this next one, I should factor the bottom, so x and x minus 6. Well, x and x cubed can be crossed off, so I know that x equals 0 is going to be a hole in the graph. But x minus 6, so in this case x equals 6, will be a vertical asymptote because that does not get crossed off. Also looking at it, my degree in the numerator is higher than the degree in the denominator, so I'm going to have no horizontal asymptote. So all I need to do is fill in my domain. Again, the values I can't have are 0 and 6. So negative infinity to 0, union 0 to 6, union 6 to infinity. On to the next one. Factoring my numerator, we're going to get x minus 3, x plus 3, difference of squares. And here, what multiplies to negative 27 adds to negative 6? That'd be x minus 9 and x plus 3. We can see that x plus 3 and x plus 3 cancel. So I know that negative 3 is going to be a hole in the graph. We can see that they have the same degree. So my horizontal asymptote is going to be y equals 1 over 1, or just y equals 1. And x minus 9 is going to be my vertical asymptote. So it has to be x equals 9. So which values can I not have for the x value? Negative 3 and 9. So my domain, negative infinity to negative 3, union, negative 3 to 9, union 9 to infinity. This next one, this is sneakily difference of squares again. These both have perfect square roots, so I get 2x minus 3 and 2x plus 3. And over here, I can factor, multiply as negative 28, adds positive 5. That would be x minus 3 and x plus 8. I have nothing to cross off, so I know that x equals 3 and negative 8 are both going to be vertical asymptotes. My original degrees were the same, so my horizontal asymptote is going to be y equals 4 over 1, or just y equals 4. I obviously have no holes in the graph, so I didn't cross anything out. So my domain is just going to be negative infinity to negative 8 union, negative 8 to 3 union, 3 to infinity. Okay. Thank you for listening, and I hope you have a wonderful day.